Hello again, this is Hallicrafters Rehabs, and welcome back. Thanks for tuning in again. As I left it last week, I had put this second oscillator mixer box back into the set, and it's but I had not tested it yet, other than to do the DC ohm tests, resistance tests, which checked out well. And what's left to do is we're going to have to put the face on partially enough to give it a shot and see if we fix the lower side band oscillation and the selectivity switch issues and so forth, and see if these things are corrected. I had a good visit with my dad, 100 years old, and he's a little bit weaker this week than he was last week, kind of struggling with his walker, but tried to get as much exercise as we could, and we built a little gentle sloping ramp from the house to the garage to make it a little easier to use his walker when he can. Excuse me. But before I do this, I want to talk about this mixer box. And the way it works, the yellow highlighter is the boundaries of the box. And this, my mind's gone on this 12AT7, yeah, 12AT7, the other's a detector, is a dual triode. 12AT7 is a dual triode, and it either selects the left side or the right side based on whether you're doing lower side band or upper side band. And the way that's done is there's a green lead that comes out of the box, and when you have the function switch in the lower sideband position, then this is grounded. And when you have that grounded, you have a RLC resonant circuit to the cathode of this triode. And that, in conjunction with this, on this side is a 1600 cycle, or 1600 kilohertz crystal. So it oscillates at 1600 kilohertz. And then when you switch to upper sideband or to the high cut or the normal, then this is open, and the yellow lead coming out is grounded, and you have the RLC circuit over here. This is about 22 millihenries. This is 0.01, and this is 100,000. When you run the calculation, the peak resonance is at 10 kilohertz, but at the resonance of these crystals, this presents about a 330 ohm impedance on this side, and when on this side with the 1700 kilohertz crystal presents about a 350 ohm impedance on that side. So you're basically you have two oscillators, and you select which oscillator you're going to use. Now, how does that work? Well, the oscillator comes in this way, either at 1600 or 1700 kilohertz. The signal in is at 1650. So the resulting mixed signal you have everything's added and subtracted, and you have all these harmonics. But there's a 50 kilohertz subtraction on the lower side band, or addition on the upper side band, which is what actually is filtered out through here with these two 50 kilohertz IF transformers. Essentially, what they've done is they've separated the primary from the, they're actually two different boxes, but this the two are linked together through this capacitor, and you're getting a 50.5, you'll tune it to 50.5 kilohertz out, and that is the second IF that is amplified and then passed on to the detector. So what it allows you is selectable lower side band or upper side band right here, and it's a fabulous design. And this is the this is the bandpass coil for the oscillator, whether it's on the left side working through here or the right side working through here. And that's the top side is lower side band, and on the underside of this is the upper side band. These are those two 50.5 kilohertz IF. Really, it's a filter at this point for only the 50 kilohertz IF. Now, when we get to the notch filters, they're working in the 50 kilohertz IF world, I should say, part of the design. And so you'll be able to run a notch up and down from that in that 50 kilohertz signal before it gets to the detector. So next step is to put the face back on. I'm only going to attach it a little bit, then we're going to run our tests. Alright, 1 hour later, and 2 redos on this when I put the selectivity knob on and found that it was loose. Oh, I didn't realize I turned it on. Sensitivity maximum. I'm on band 3. The lights are burning. Getting these knobs tight is not easy. I did get the switch in there tight. There we are. All right. Alright, that's band 2 with just a shop antenna. Band 1. Uh-oh. Still silent. On band 0. Now I've rebuilt the coil, I've rebuilt there's something else. I'm seeing something. Now what we have is an alignment issue. So band 1, there's something there. Hooray, hooray. BFO. Alright, that's normal. Treble cut. Upper side band. Still not good. Oh, we have to do something to get us oscillation. I lost my alignment tool in all this mess. We'll have to come back, find it. Okay, never fear. As far as this is adjusted way off. So we're in band 1. Let's go to band 2, where it's real loud. Lower side band, and nothing's there. And we're losing control of our tool. But what I'm doing is moving the slug on the lower side band, the 1600 side of the tube, all the way out. See if we can get oscillation. Did you hear that? Success. Just to play around. And band 1. Okay. Well, big success. Band 2, band 3. Can hear the different selections on the selectivity, excitement. Why don't we turn the volume up? I was doing it the opposite direction for volume. Should be Spain. It's ungrounded too. When I ground it, I get a lot better reception. Okay. Now band 4. Whoa!
suiting your own foot. Many people don't understand that. You'll be surprised how much they don't know.
I love it when the radio comes together. Alright, we're going to put the knobs on, and the next step will actually be alignment, which it badly needs.
Because if the negative cannot hit me, they hit them. It happens.
Well, I need to turn this on just to prove it. Wow. I've been working on this, I don't know, 3 days? Not 3 days, but off and on for 3 days. And the first problem encountered was we're listening to band 1 and a station on it. I'll just turn it back down again. There is that capacitor back in the back there, which is now abandoned in place. And the reason why it was silent on band 1 is there's a screw that anchors down the main tuning gang, and I just happened to put the wrong size screw. It was too long. It was grounding out that capacitor. So once I figured that out, we still weren't getting anything, and just every kind of option, different ones of these, just temporary capacitors. Maybe we can find the capacitors. These are all messed up. Maybe we can find the capacitor combination that would be the substitute for the trimmer behind there, which I commonly do. Here's one of my concoctions there. It's got 3 different capacitors in parallel to reach a certain value. None of the above. Different configurations of these trimmers, different size trimmers. This is a smaller trimmer. This is a large size. It goes to about 250 from maybe 20 or something like that. And the one behind it is from 120 to 200. And nothing was happening with the one behind it, no matter what setting you had. But with this one, finally, I went back to the basics, okay? And the other thing, I also had a miswire. So, went back and retraced everything, got it in the right configuration. And this, it's really funny. It works really well when it's in the right position. You get radio stations and everything else like that. But listen what happens when I turn it off frequency. Just a little. That's a local station that overdrives a lot. Now I turn this. Very sensitive.
Los artistas todos los días actúan. Te platico un poquito de Lina en
So that's at 790. And we'll just do the RF just for a second. Doesn't do much. Okay. So, at any rate, very sensitive. And I probably still have to do a little bit of. This is a 3 picofarad NP0 I just threw in there trying to change the bandwidth. I'll probably take it back out or maybe experiment with different values there. But this was a bear getting, and it's not even over the whole band, so I'm almost certainly going to take that out. Let me see if I can get a little better sensitivity at that area. Sensitivity is directly related to how well the oscillator. There we go. Look at that. Okay. And that's just quick and dirty kind of alignment, just to get things started. So I got to clean this all up. I've got band 2 just taken out of there just so I can work with band 1. Get that back in, and then hopefully it'll work well enough that I don't need to do any more of this, and we can button it up for alignment. Let me see what I can do here. Okay, well that pretty much finishes up this thing. I can button it back up now for alignment, but put the knobs back on for the 4th time. You have to align. You have to align band B. This violates my maintainability, but you're going to have to take the case off and remove this from the screw in order to align band B, which won't align very well anyway. This is going to have a digital frequency readout, so that won't matter a great deal, but it's part of what was necessary to make everything work. So we'll call this quits for this week, and we'll be cleaning it up a little bit Thursday, and then getting it ready for alignment. So this is Hallicrafters Rehabs. Thanks for watching.